Have you ever looked at Raphael's School of Athens? That amazing painting?
Oh yeah, incredible piece. All those philosophers debating.
Exactly. All that, intellectual energy bouncing around. It makes me think about what's happening now with AI, especially multi-agent systems, or MAS.
Yeah, it's a great analogy, actually. That idea of different intelligences collaborating or maybe even arguing to reach something bigger,
Hmm.
that's sort of the core of MAS.
It really is. And that's what we're diving into today. There's this paper, The Athenian Academy, a 7-layer architecture model for multi-agent systems by Zai and others.
Ah, yes, I've seen that one. It tries to put some structure around MAS development.
Right. And for our listeners, especially if you're an engineer working with these systems, this framework seems, well, super useful, a way to really break down the different facets.
I agree. It moves past thinking of MAS as just one big thing. Instead, you get these 7 layers.
Mm.
Makes it easier to grasp the specific challenges at each stage.
Yeah, like a roadmap. We're going to walk through these 7 layers, from basic collaboration right up to merging agents together.
And hopefully for the engineers listening, this gives a clearer picture for design choices, evaluation, how to really get the most out of these systems.
Okay, so let's jump in. Layer 1, multi-agent collaboration. This is the bedrock, right?
Pretty much. Just getting multiple autonomous agents, intelligent ones, to actually talk and work together, share information, cooperate on tasks, especially complex ones like maybe AI art creation.
The goal being to achieve stuff that one agent alone just couldn't manage. You get different perspectives, maybe more optimized outcomes.
Exactly. It's about synergy, not just numbers. And the paper validates this with a really interesting experiment.
The philosophy debate one.
Yeah. They set up agents representing Aristotle, Plato, and Socrates to debate art.
That's brilliant, each with their own philosophical angle.
Right. Aristotle focusing on mimesis, art's social function, Plato, more critical theory of forms,
Mm.
and Socrates doing his Socratic questioning thing.
So for an engineer building this, it's not just about agents talking. It's about having agents with genuinely different perspectives or ways of processing.
I think that's a key insight. You want that productive friction, not just groupthink. Otherwise, what's the point of multiple agents?
And they debated real topics, not
Oh,
just abstract stuff.
oh yeah, concrete things. Social rights in art, AI art's place in academia, ethics of creation, science-art fusion,
Mm.
even things like rural art practice and traditional values. It was quite comprehensive.
Wow, okay. And how did they measure if this philosophical chat was actually good?
They had some smart metrics. Critical depth was the debate intellectually solid.
Hmm.
Human expert rating, did people think the output was good? Collaboration fluency, did they interact smoothly?
Okay.
Plus theme consistency, did the art connect to the debate? And even artistic emotional expression.
So for the engineers tuning in, layer 1 says, think hard about how your agents collaborate. What are the communication channels? What defines a good collaboration beyond just finishing the task? How do you build in that useful diversity?
Makes sense. Okay, layer 2, single agent multi-role playing.
Right, so now we're zooming in on one agent, but it's wearing multiple hats.
Exactly. A single AI that can shift its behavior, its decision-making, based on what role it needs to play for a specific task.
The big plus here is adaptability, I guess. More flexible than having, say, 5 different specialized agents.
Potentially, yes. Increased flexibility. And the experiment they used is quite clever based on the artist Kiyiziji.
The contemporary artist, how did that work?
They built a virtual art education platform where one agent simulated Kiyiziji's different professional identities,
Like what?
like art educator, international communicator, and experimental artist. 3 distinct roles within one agent.
That's fascinating. Did they give each role its own knowledge base?
They did. The educator knew art history, pedagogy was rigorous. The communicator knew English art terms, was more open, bilingual. The experimental artist knew Kiyiziji's work, contemporary theory, was more radical. They even tried to model personality traits.
And the tests.
2 main ones. First, multi-role coherent dialogue. Could it switch roles smoothly within one conversation?
Okay.
Second, role conflict testing. They deliberately created friction, like the educator emphasizing rules while the artist wants to break them. See how it handled that internal conflict.
Ah, that's crucial. How do you measure success there?
Metrics included role consistency. Did it stay in character? Knowledge accuracy. Was the info right for the role? Switching fluency. How smooth were the transitions?
Makes sense.
Also, conflict resolution ability. How well did it handle those clashes? And something they called cognitive penetration depth. did knowledge from one role influence another without totally overriding it?
So the challenge for engineers building this kind of agent is complex.
Mm.
How do you structure it internally for smooth shifts? How do you maintain consistency within each role while allowing for that flexibility?
Exactly. It's a tricky balancing act.
Okay, layer 3. Single agent, multi-scene experience traversal. This sounds ambitious.
It is. It's about one agent moving between totally different environments or scenarios
Why? What's the goal?
to really push adaptability. See if navigating diverse contexts sparks, I don't know, cognitive leaps or new ways of thinking.
Emergent stuff.
And the experiment for this.
They took the philosopher agents, again,
Wow.
Aristotle, Plato, Socrates,
Okay.
and they moved them from their usual Academy of Athens debate setting into a murder mystery scene.
What? Seriously? Philosophers playing detective?
Kind of. They had roles like detective, doctor, reporter in the mystery scene. Then they moved them back to the Academy.
So initialize in the academy, zap them to Cluedo, then back again. What were they looking for?
How well they adapted. Scene adaptability. Did the jarring shift lead to new insights? Cognitive leak strength? Could they use knowledge across scenes effectively? Knowledge transfer effectiveness.
Right, like could Aristotle apply philosophical principles to detective work? Or did the detective work change his philosophy?
Potentially, yes. Also, interaction dynamism. Did they interact differently in the two scenes? And evolution quantifiability. Could they actually measure improvement from the experience? Okay, for an engineer, this layer screams knowledge transfer problems. How do you make sure an agent learns and adapts across wildly different contexts without getting confused or losing its core abilities? That seems like a huge hurdle.
It definitely is. Ensuring that kind of robust, context-aware adaptability is non-trivial.
Let's move to layer 4. Single agent multi-capability avatars.
Right, so here we have a single agent, but inside it are multiple specialized sub-expert modules. Think of it like different departments within one company.
So one agent that contains, say, a painter module, an engineering module, a music module, all working together.
Precisely. The idea is to harness deep specialization from different fields within one unified system for complex interdisciplinary tasks,
Right.
creative projects.
The benefit being efficiency and quality, because you have these focused experts inside.
That's the hope. But the challenge shifts to coordinating them effectively. You need a good internal conductor.
And the experiment. It involved Da Vinci.
Yeah, they simulated creating a Da Vinci-esque artwork.
Yeah.
The agent had internal sub-experts for painting.
Like portrait sketches.
Exactly, Mona Lisa style. Then an engineering sub-expert designing a bridge using the golden ratio.
Reflecting Da Vinci's interests.
Right. And a music sub-expert composing using Da Vinci's water harp scale.
Wow, that's specific. Integrating all that must be tough. How do they evaluate it?
Metrics like expertise depth in each area, cross-domain collaboration efficiency, how well did the modules coordinate, style consistency across the outputs, historical restoration accuracy, did it feel like Da Vinci, and overall system robustness.
So, for the engineers out there, this layer is all about modular design. How do you build those internal modules? How do they communicate? How do you ensure they work together towards a single, coherent goal?
Big architectural questions.
Okay, layer 5 takes a different tack. Different single agents using the same large model.
Right, so multiple distinct agents, maybe with different roles, but they all share the same underlying large model, like GPT-4, or in their case, Stable Diffusion XL.
Why do that?
The main motivation is consistency. If you have agents using totally different foundational models, you can get clashes in style, fragmented information. It can be a mess, especially for creative tasks.
Ah, so grounding them all in the same base model helps them stay on the same page stylistically.
That's the idea. Better coherence, smoother integration.
How did they set this up experimentally?
They had 3 agents working on an artwork. A concept design agent for the initial idea, a detail filling agent to flesh it out, and a style unification agent to ensure consistency.
Okay.
And critically, all 3 use Stable Diffusion XL. They also built in parameter sharing and a shared context memory pool to help them coordinate.
So concept agent sparks idea, detail agent adds substance, style agent polishes.
Pretty much. Like a little assembly line, but all drawing from that same core intelligence.
And the metrics, focused on the collaboration, presumably.
Yep. Dynamic collaboration efficiency. How smooth was the workflow? Style fusion depth. How well did the styles blend? System fault tolerance. Could the system handle one agent failing? And decision diversity. Do they still show some individual variation despite the shared model?
Interesting. So for engineers, this raises trade-offs, doesn't it? Tightly coupling agents via one model might boost consistency, but does it limit flexibility or the unique voice of each agent?
That's the balancing act you'd need to consider, yeah. What do you gain? What might you lose?
Okay, layer 6 flips that around. Single agent using different large models.
Exactly. One agent, but it's strategically pulling from the strength of multiple different large models.
Like a Swiss Army knife agent, knows which tool or model to use for which part of the job.
Kind of, yeah. The idea is that no single model is perfect for everything, so let the agent intelligently pick and choose to get better accuracy, robustness, or efficiency.
And the experiment here.
They had a single agent generate art on the theme, intertwining of dreams and reality.
Evocative theme.
And to do it, the agent used DALE3, maybe for the abstract, dreamy concepts.
Okay.
Midjourney, perhaps for adding richer details and emotional tone, and Depart, maybe for applying specific artistic styles or enhancing realism. It dynamically selected which model to use for different phases.
That's sophisticated. Leveraging the best of each world.
If it works well, yes. Evaluation focused on model switching agility. How fast and seamlessly did it switch? Style quantum entanglement, which sounds cool.
Yeah. What does that mean?
Basically, how well did the different model outputs blend into a cohesive whole that fit the theme? Also, fault propagation block rate. Could it isolate errors from one model? And resource competition balance, managing the compute load.
So the engineering puzzle here is building that internal decision maker. How does the agent know when to use DLEE versus Midjourney versus something else? How do you orchestrate that dynamic selection?
That's the core challenge, building that strategic layer within the agent.
Which brings us finally to layer 7, multi-agent synthesis into a single target agent. This sounds like the ultimate endgame.
It's a fascinating concept. You take multiple agents, have them collaborate, but the end goal is to actually merge them into one more powerful synthesized agent.
Combining their strengths, creating a super agent.
Essentially, yes. Taking the specialized knowledge or capabilities of several agents and integrating them into a unified entity that's hopefully better, more robust, more adaptable than any of the individuals.
Like Voltron for AI agents.
Oh, maybe. The paper talks about the tech needed, like global coordination and information fusion mechanisms to make sure the merged agent thinks coherently.
Okay.
A collaboration gain model to prove the sum is actually greater than the parts, and distributed fault-tolerant mechanisms so the new agent is resilient.
The overall aim being a leap in robustness, adaptability, efficiency for these highly integrated systems.
Right. And for engineers, this top layer poses some major architectural questions. How do you actually do that merging? How do you fuse knowledge and capabilities from distinct agents into one cohesive, functional entity?
It's a complex vision. So looking back at this whole Athenian Academy framework, it really does give engineers a structured way to think about MAS, doesn't it? From basic teamwork up to this kind of advanced synthesis. It covers a lot of ground.
I think it's very valuable for that reason. It helps categorize the problems and the approaches, whether you're working in AI, art, or frankly, any domain where MAS might apply.
Of course, the paper acknowledges it's not all solved. There are still big challenges.
Absolutely. Optimizing collaboration, making model fusion stable, dealing with scale and security.
Yeah.
These are all active research areas. The authors even mention things like meta-learning or federated learning as possible ways forward.
Which leads us to a final thought for the engineers listening. You've heard these 7 layers, this framework. Thinking about combining them, what kind of novel hybrid architectures could you imagine?
That's a great question. How could you mix and match? Maybe a multi-role agent that also uses multiple models dynamically.
Or maybe collaborative agents that are designed from the start with the goal of eventual synthesis. How could combining elements from different layers lead to systems that can tackle even bigger, more complex real-world challenges?
Lots to think about there. How these layers could intersect and build on each other. That's where the really interesting future designs might lie.